Hello students, how are you today? Today I do have a lecture for you for equations for chemical reactions, in which I'm going to do an experiment for you. I have reactants, they are going to react with each other. There will be a new observation and there will be a new products. For example, here the tarnishing of silver. The silver, it had been tarnished because whenever the solid silver reacts with the sulfur in the air to make solid silver sulfide, the black material, we call it tarnish. Like in silver, whenever it had been exposed in a humid area in the moisture, it will turn into a tarnished silver. Ag2S, it had been stained, this jar. Okay, a chemical change occurs when a substance is converted into one or more new substance. In some reactions, we see color change. Other reactions, we see gas bubbles. Other reactions, I may see a solid, a precipitate already it had been formed as a product. But of course, we have to write abbreviations or something to show that what I had got exactly. Did I get as a solid? I have to write S if I got it in the form of a solid. Is it a liquid? I just write L. Is it a gas? I should write G. Is it in the form of aqueous? Well, therefore, I have to write AQ. Like reactants are written on the left, products on the right. Here, for example, I do have the reaction. I have the reactants carbonate plus H plus. I do have them, both of them, in the aqueous form. Whenever they react together as reactants, I will get products. The product is going to be in the form of carbon dioxide. It's the gas. I do have the other one here, AgNO3, in the form of aqueous form, these ions. And whenever I add it to Cl minus chlorine or Na plus in the form of aqueous, these reactants, they react together, I will get a precipitate in which it says AgCl, solid. And as you had seen that, I had an arrow downward. And why? To tell the observer I've got AgCl in the form of a solid. There is also, if for example I had heated the reactant in such a way, here calcium carbonate, it had been heated. The sign for this heat is delta. We just put delta. And I've got the product in the form of calcium oxide plus carbon dioxide, which is CO2. Here I have other examples for you. Methane gas in an outdoor heater burns with a colored flame. What do you see? What's the observation here? The methane gas in an outdoor heater burns with a blue flame. You had seen that? There's a blue flame as an observed. And it had been, of course, heated in order to see this blue flame. Whereas, for example, the shirt, it had been bleached. Therefore, there is a change in color. It had been bleached. This is the observation that you had seen. Whereas, whenever, for example, you put baking soda to vinegar, you will get what? Carbon dioxide as bubbles. And you had seen it here in the picture. You do have it as bubbles. Okay. Now, I am going to do an experiment for you in which it is qualitative analysis of anions experiment. Let me put here the goggles on my eyes and do for you the experiment for this. The reactions that they are taking place here, or the experiment that we do it here in the lab, and the students, they do it one by one, testing for chloride, testing for sulfate, testing for nitrate, carbonate, and phosphate. As you had seen that there is a new product for each. For chloride, whenever I put chloride to Ag plus, I should have AgCl in the form of a solid white precipitate. Barium sulfate, it gives me barium sulfate. This is a white precipitate. Iron with the nitrate, testing for nitrate in a very acidic media, I just got a brown ring here. The fourth test for checking for the carbonate, whenever I add H plus to carbonate, I will get bubbles of carbon dioxide. Whenever you open the carbonated soda bottle, what do you see? You see carbon dioxide gas. It goes out of the carbonated soda bottle, right? What about the fifth test? For example, if I have the reactants as phosphate with ammonium, with the molybdate, in the form of an acidic media, HNO3 here, I will get a big precipitate in which it is a yellow precipitate, ammonium phosphate molybdate solid. Hello, I'm going to do for you the sort of experiment in order to see by yourself how do we get these precipitates or the bubbles. Here you can see that I have a known solution, and this known solution, I have the ions. By the way, the students, they tell me, Miss, do we have these? It looks like distilled water, this one. Okay, yes, I have them. I'm going to test for them. How am I going to do this? So I just take a test tube. I'm going to take almost 10 drops from this one, from the original solution that I have the ions in it. And now I am going to acidify this solution. It needs acidification for the reaction to take place. Here I'm going to add HNO3, and look, whenever I add HNO3, it had been acidified, the solution. You had seen bubbles of gas. What is this? This is carbon dioxide, because already, and I'm acidifying, already I have here carbonate inside my solution. But here and now I'm testing for chloride, for Cl minus. Okay, I had acidified the solution with HNO3. Now what am I going to add? I am going to add AgNO3. Ag, whenever I add AgNO3, Ag with Cl, I will get directly a precipitate, which is AgCl white precipitate. And you can see that this is a very fast reaction that it had taken place. Okay, I do have the other test for carbonate, in which you are going to see the bubbles. As I told you, whenever you open the carbonated soda bottle, you have the carbon dioxide gas. Okay, here I'm just taking almost 10 drops from the original sample, this one. I am going to put HCl. Whenever I add HCl, look, a whole bunch, you will see effervescence of carbon dioxide. It's coming up. This is a new observation. This is the product that I've got. Of course, I have to write here in this case, arrow upward and gas. Okay. What about, for example, here, testing for phosphate? Testing for phosphate, here you are going to see a yellow precipitate. I'm going to take here 10 drops from this, from the original solution, almost 10 drops. I am going to add to it ammonium molybdate from here. I'm going to add almost 5 to 6 drops. This one, I'm going to show it to you, by the way. Look, ammonium molybdate, 1 molar. I'm going to add almost, 5 to 8 drops. And now I am going to, it needs a little bit of heating, by the way, this reaction. What do? I have to hold it with a test tube holder like this, and I put it in a hot water bath, and you can see that it needs heating, by the way, but I've got it almost, this yellow precipitate, before I had heated it, because already it had been concentrated. Therefore, I have to heat it for some time, for about 1 minute, and then I go and I check. It's a turbid solution in which I do have this precipitate, which is ammonium phosphate molybdate solid. You had seen by yourself that reactions that had been taken place, and this lecture is about reactants. It had been turned into new products. Good luck for you, and I hope that you had enjoyed the lecture. Thank you.